Hey everybody, video number 5, spontaneous reactions. This should be a quick one. We just got to differentiate between spontaneous and non-spontaneous using table J. This will set the stage for differentiating between our voltaic and electrolytic cells. Okay, so activity series, we've used this table J in the past before. Lists a bunch of metals based on their reactivity. The metal above is the most reactive, and if we know that, then we can predict if a reaction will be spontaneous or not. So a spontaneous reaction will go forward without needing any energy. That is just like the definition of what it is, and then we use table J to figure it out. So when the lone metal, listed as just an atom, on the reactant side, is above the bonded metal on table J, that is the metal within the compound, right, then the reaction will be spontaneous. It's that simple. We're going to look up the two metals. If the metal that's all by himself is more reactive than the bonded metal, he will react with the bonded metal and replace it, and it will have a single replacement reaction. A non-spontaneous reaction needs some energy. It doesn't go all by itself. And then in this case, the lone metal will be below the bonded metal on table J. And we're going to go through some examples and make sure we know what's what. Okay, so I have table J. Oh, it should be white. It's a little gray, but that's okay. I think it'll still work. And I'm just going to literally look at my two metals. So I have Zn and I have Pb. If Zn is the lone metal, is more reactive than Pb, then it will go. So Zn is here, Pb is here, Zn is higher and more reactive. So boom, he is going to swap out. Pb will be by himself, and then Zn is moving in where he was. Single replacement reaction. A plus BC equals B plus AC. If you need to code it. Okay, we're going to do another one. Again, I'm going to check the first metal, the lone metal first, and then the bonded metal. So Zn, and Zn is below Ba. Ba is more reactive than Zn, so in this case, no reaction. This is what we call a non-spontaneous reaction. So by itself, it won't just go. We're going to have to add energy to make this kind of thing happen. Okay? All right, next one, I'm going to look up Ca, and I'm going to look up Cf. I'm going to stop underlining them. I think we got a feel for it now. So I'm going to do Ca, and then I'm going to look up Cr. Sorry, I said Cf. And Ca is higher than Cr, so double replacement. Cr and Ca are going to swap, and I have this kind of a reaction listed. Okay, do another one. Mn versus nickel, manganese, and nickel. So I find manganese, I find nickel. Manganese is above nickel, so yes, this will go. They will swap out single replacement style, and notice just the metals swap, and the non-metal is still sticking around bonded. Okay, he's kind of like the spectator in this guy. All right, now I have iron and magnesium. I look up iron. I look up magnesium. Magnesium is higher than iron. The bonded metal is higher, so no reaction, at least no spontaneous reaction. Okay, I would have to give it energy. Last one, cobalt and lead. Notice that lead is below cobalt, so it will react. Switch out the lead and the cobalt, and we just used table J to predict reactivities and a quick review of single replacement reactions. We have done those before, so I didn't spend an entirely large amount of time in predicting which way they would go. But with that, we're out.